Hey mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. Guys, I'm actually very excited because I'm going to actually be starting with the pure mathematics learners content, right? And I'm going to be focusing on the grade 11s and the grade 12s for now, okay? And in the next upcoming video tutorials, guys, I'm going to be going through the area rule, the sine rule, the cos rule, right? As well as the proofs of all those rules. Okay, so if you know that you're currently struggling with the sine rule, the area rule, the cos rule, please make sure that you are subscribed to the channel. And please make sure that you share the channel with your friends, because I'm going to be going in detail when it comes to these topics. Okay, so before we get started with today's video tutorial, guys, please make sure that you are subscribed to the channel. Please make sure that you click on that notification bell so that you get notified every single time I upload a new video tutorial, guys. And also don't forget to give this video tutorial a huge thumbs up, because that really helps the channel grow and it helps the channel to reach more learners that want to better their mathematics marks. Okay, so without any further ado, guys, let's get started with today's video tutorial. Right, so in this video tutorial, guys, I'm going to be focusing on the proof of the area rule. Okay, but before we even get started, guys, right, what is the area rule? Okay, so we know, guys, that when you're basically calculating or dealing with triangles, right, we can basically calculate unknown sides and unknown angles, right, by using our trig ratios. So katoa, if you are basically dealing with a right angle triangle, right? So if you're given a right angle triangle, it's very easy for you to use the theorem of Pythagoras to basically calculate maybe the length of an unknown side. We can also use trig ratios, your SOHCAHTOA, right, to help you basically find an unknown size of an angle or an unknown length of a side, right? So we can use our trig ratios, okay? But now the problem basically starts when you do not have a triangle that is a right angle triangle, right? So when you do not have a right angle triangle, that's when we now start to use the sine rule as well as the cos rule to basically help us calculate the lengths of unknown sides as well as the size of unknown angles, right? Okay, and then we know that we can basically use the sine rule if you are basically given a triangle that has two known angles, right, and one known side. And we can also use the sine rule if you are given a triangle, right, that has two known sides and one known angle. That is not an included angle, right? But I'm going to go in depth when it comes to that when I go through explanations of the sine rule, okay? And we can basically use the cos rule, right, when you are given three known sides, okay, and a side angle side, meaning that two sides and an angle that is an included angle. Okay, so now what happens when we're basically dealing with the area rule? Okay, for you to basically apply an area rule to a triangle, right, you need to have two known sides and one angle, right, or one known angle that is an included angle, right? Okay, but what do I mean by that? Let's say, for example, right, you were given side AB, and then this side was actually 12 centimeters, right? And we're given side AC, and we're told AC was 17 centimeters, and we're given this angle as a 70-degree angle, right? In this case, we would be able to basically apply the area rule to calculate the area of this triangle ABC, because in this case, right, we see that we've got two known sides. So this is a known side because AB is known, and AB is equal to 12 centimeters, and AC is known because AC is equal to 17 centimeters, and we've got what? An included angle, right? So an included angle, guys, is an angle that is between two known sides, okay? And then because we know that now in this case we've got a side and we've got an angle and we've got a side, right? Side angle side, then we know that we can basically apply our area rule to basically calculate the area of this triangle. Okay, but that's not what I'm going to be doing in this video tutorial. In this video tutorial, guys, I'm going to be basically taking you guys through the proof of the area rule. So please make sure that you follow and you take down notes. Okay, so how do we basically start off this proof? Okay, we know that, right? If you are given this angle and you're told that this angle is angle A, we know that the side that is opposite our angle A, right, this side BC, can also be written as side A, right? So the length of side BC is A, right? Okay. And the length of the side that is opposite our angle B, right, is B. And the length of the side that is opposite our angle C is C, right? Okay. So that is basically very important when we basically starting off our proof, that you are basically well aware of that. Okay. And I'm going to start off with the proof of when you are basically dealing with an acute angle triangle. Okay, so if you are given an acute angle triangle, right, how would you basically prove the area rule? Okay, so what is an acute angle triangle, guys? An acute angle triangle is a triangle where all the interior angles of that triangle are less than 90 degrees. Okay, so how do we start off this proof? We already know that, okay, to calculate the area of this triangle, okay, if you wanted to basically calculate the area of this triangle, we know to calculate an area of a triangle is half the base, right, multiplied by the perpendicular height. Okay. However, in this case, we do not have a perpendicular height. Okay. So that's when we're basically going to draw a construction line from our angle A going all the way to our side BC, right? And that is now our perpendicular height. And we're going to put that point there as D. Right. So in this case, if we have to substitute our base and our height into this formula, we'll say that half the base. What is our base in this case? Our base is BC, or we already know that the base is A. Okay. Multiplied by what is our perpendicular height? Our perpendicular height is that construction line that we've drawn there, which is AD. All right. So that's basically our starting point, right? What's going to help us to get to our proof. Okay. So now we're not done. Okay. We already know that. Okay. When we're dealing with our area rule, what would the area rule basically look like? Okay. What are we trying to prove? So just to show you what you're trying to prove, right? If you're given triangle ABC, right? And we already know that our included angle, let's say for example, is B, right? And we are given sides C and A. Okay, let's say for example, this was our included angle here, right? We're given this included angle and we're given sides C and A, right? We'd know that, okay, right? To get the area of triangle ABC, we would just say half, right? Side A multiplied by side C times sine of the angle between them, right? That is basically how we would calculate the area of this triangle if we were given two known sides and one included angle, right? So this is what we are basically trying to prove. We are trying to get to this point here, right? So to start off our proof, we already know that to calculate an area of a triangle, we know that it's half base multiplied by perpendicular height. Then we draw a construction line from A going all the way down to side BC, right? And we labeled that construction or perpendicular height AD, right? And then we basically substitute it, okay? And then now we already know that, okay? Okay, I made a mistake here. Sine of the angle between the two known sides, which is B, right? Okay, that's fine. Okay, and then here we already know that we want to have that sine of B in our equation, right? So that basically is a guide on where we need to basically focus for the next part of our proof, okay? So in this case, we know that we're actually going to focus on triangle ADB, okay? So in the next part of our proof, we will say that in triangle ABD, okay, what do you notice about triangle ADB? So now, right, when we basically focus on triangle ABD, right, we see that this triangle is a right angle triangle, right? And we know that in our formula, we've got AD, okay? So we want to basically determine what the length of AD is. So we can basically determine the length of AD using trig ratios, your SOHCAHTOA, right? Okay, because we now know that we've got a right angle triangle. Okay, so in triangle ABD, we can just find what sine of B is, right? Using our trig ratios. Okay, so what is sine of B? Sine of your angle B is your opposite, which is your AD, over your hypotenuse, right? And your hypotenuse is AB. Okay, so from here, we know that we're trying to find out what is AD, what is the length of AD, right? And then here, guys, we already know that AB can be written as C, right? So we can just say sine of B is equal to AD over C, right? And then all we need to do here is we need to basically have AD on its own, because once we have AD on its own, right, then we can substitute this equation back into this equation and we would have basically proven the sine rule. Okay, so all that we need to do here, if you multiply the right hand side by C, what you do on the right, you need to do on the left, right? Therefore, C times sine of B is equal to AD. And then we'll call this our equation 2. And all that's left for us to do in this case, right, is just substitute equation 2 into equation 1. And we would have basically proven our sine rule, right? Therefore, right, the area of triangle ABC is equal to half, right, your A multiplied. What is AD, right? We've already found out what your AD is. That is our AD. So all that we need to do is we need to substitute that AD into our equation, which is C sine of B. And from here, what do we see, guys? We have basically proven our area rule. So very important when you want to prove the area rule, when you are dealing with an acute angle triangle, start off with what you know. When you're dealing with an area of a triangle, how do you calculate area of a triangle? Area of a triangle is half base times perpendicular height, okay? And then we can see that here, initially we didn't have a perpendicular height. So we drew a construction line from angle A going all the way down to your side BC. And we called that line AD, right? And that line AD is perpendicular to line BC, all right? So from there, we could just substitute. What is the base? That base is BC. However, BC can also be written as A, right? Times, what is the perpendicular height? AD. Okay, then the next step, right? What do we now notice? We want to write AD. We want to find out what is the length of AD, okay? And we see that for us to find the length of AD, we can just use triangle ADB, right? Okay, and we know that with triangle ABD, we've got a right angle triangle. And when we have a right angle triangle, we already know that we can now use trig ratios to help us find lengths of unknown sides and unknown angles, right? So now we know that we can basically use sine, your SOHCAHTOAs, right, to help us find AD. So in this case, sine of B, right, because we already know that the area rule has sine, right, sine of the angle between two known sides, right? So the sine of our angle B is going to be your opposite side, which is AD, over your hypotenuse, which is AB, right? And then here we already know that this hypotenuse can be written as C. Okay, so you need to write that down. And then from here, we know that we just want to find out what AD is. So I basically multiplied by C on both sides. And then from there, I was able to substitute, okay, this equation 2 into my equation 1. And in this case, right, we would have basically proven our area rule. All right, so that is it for today's video tutorial, guys. I hope you guys enjoyed the proof of the area rule. Please make sure that you are subscribed, guys, because in the next video tutorial, guys, I'm going to be taking you guys through the proof of the area rule if you are given an obtuse angled triangle. I'll see you guys on my next upload. That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.